Hey class, now that you've had your introduction to algebra and what variables are and equations and expressions, we're going to continue to work with balancing those equations. So Mr. Miller has put together an awesome video for you that is included in this. So, and then at the end of it, there's a number of problems that you're going to work on for your homework. Good luck.
Algebra lesson number 2, working with equations. As you learned in the first lesson, an equation has an equal sign and a number sentence on either side of it. Both sides have to equal each other. Solving equations is like making a balance pan even on both sides. Both sides have to have the same amount in order to be balanced. So in the image below, both sides equal 15. In algebra, there's going to be variables that you will need to figure out in order to balance both sides. So I'd like you to watch this Khan Academy video, and he explains the same concept with the balance pans.
We've got a scale here, and as you see, the scale is balanced. And we have a question to answer. We have this mystery mass over here. It's a big question mark on this blue mass right over here. And we also have a bunch of I guess we could call them 1 kilogram masses. So these are all each a 1 kilogram mass. And my question to you is, what could we do to either side of this scale in order to figure out what the mystery mass is? Or maybe we can't figure out at all. Is there something that we can do, either removing or adding these things, so that we can figure out what this mystery mass is? And I'll give you a couple of seconds to think about that. Well, to figure out what this mystery mass is, we essentially just want this on one side of this scale. But that by itself isn't enough. We could just remove these 3, but that won't do the job, because if we just remove these 3, then the left-hand side of the scale is clearly going to have less mass, and it's going to go up, and the right side is going to go down. And that's not going to give us much information. It's just going to tell us that this blue thing has a lower mass than what's over here. So just removing this won't help us much. It won't let us know that this is equal to that. What we've got to do if we want to keep the scale balanced is we've got to remove the same amount of mass from both sides of the scale. So if we want to remove 3 things here, so let me try my best to remove 3 things here. If we want to remove 3, let me do it like this. I'll just erase it. So if we want to remove 3 things there, if we did this by itself, just removed these 3 things, then the 2 sides would not have an equal mass anymore. This side over here would have a lower mass. So we've got to remove 3 from both sides. So if we really want to make sure that our scale is balanced, we've got to remove 3 from both sides. And so if we started off with the scales balanced, and then we remove 3 from both sides, the scale will still be balanced. And then when we do that, we have a clear idea of what the mass of this object actually is. Now, when we remove 3 from both sides, the scale will still be balanced. And we know that this mass is equal to whatever's left over here. It's equal to 1, 2, 3, 4, 5, 6, 7. And if we're assuming they're kilograms, we'll know that the question mark mass, the question mark is equal to 7 kilograms. That this right over here is a 7 kilogram mass.
So this is the beginning of solving equations. The goal is to figure out the variable. In the first set, you need to figure out how many marbles weigh as much as 1 orange. There are several steps in solving these problems. The first picture is the problem. So we have 3 oranges on the left side, 1 orange, and 12 marbles on the right side. Our goal is to figure out how many marbles equal 1 orange. So for the first step, they removed 1 orange from each side. Now we have 2 oranges and 12 marbles. So now the second step is they remove 1 of the oranges and half of the marbles, because they removed half the oranges and you move half the marbles, and it turns out your answer is 6 marbles equals 1 orange. For problem 1 down below, we have 2 pencils and 40 paper clips on the left side, and we have 5 pencils and 10 paper clips on the right side. Our job is to figure out how many paper clips equals 1 pencil. First step, we can remove these 2 pencils on that side, and then we will move 2 pencils on that side. Now what we have is 40 paper clips on the left side, 3 pencils on the right side, and 10 paper clips. The next step is we're going to move these 10 paper clips off, and we're going to take 10 off of the 40 on the left side. That leaves us 30 paper clips here and 3 pencils. So now I have 30 paper clips on the left side, 3 pencils on the right. Well, I'm trying to figure out how many paper clips equals 1 pencil, so this now becomes a division problem. 30 divided by 3 is 10, so we are left with 10 paper clips equaling 1 pencil. Problem number 2 has 5 pencils and 13 paper clips on the left side, 4 pencils and 15 paper clips on the right side. Just as in problem 1, we need to know how many paper clips equals 1 pencil. So my first step is I see that there are 4 pencils here, and if I take those off, and then I'm going to take 4 pencils off on that side, I end up with 1 pencil. Now I have 15 clips on this side and 13 clips on this side. I'm going to take off 13 from that side, and then I have to take 13 off of this, leaving me 2 clips. So now I end up with 1 pencil equaling 2 paper clips. Now it's your turn to practice. You may need to redraw some of these problems on a sheet of paper, or do the work on this page and take a screenshot of your work and submit it. In some cases, the answer is going to be obvious, like in number 3, how many marbles equals 1 banana. In other cases, you're going to have to do some removing of the items. For instance, in number 4. You've got 1 cube and 5 clips on one side and a bunch of clips on the other side. So you're going to want to move some of the clips so that you can figure out how many clips equals 1 cube.